Hey everybody, Amplifier.com, 203-892-4119. So I've been super busy here in the shop. Been waiting on parts. Some parts showed up late today for a 30L1, so I'll get to work on that on Monday. It's Friday right now, TGIF. So if you haven't hit the subscribe button, I recommend you do it now if you want to get a notification when I put more repair videos up and also more videos on this amp. I have lots of other videos on this build, so if you want to see from the start to this point where I'm at now, scroll back and you can watch them. Lots of good information. So in the last video I went over the band switch, that setup. So I'm going to add a bracket. I'm going to put a standoff here and then support this with a piece of strap. And I'll put it not on the shaft but in this part just to pull it over a hair just so it lines up with the bushing in the front panel easier. I ended up damaging the ceramic shaft for the band switch. It was already cracked and it ended up breaking. So this switch is rated for 20,000 volts I think, or 24, and I'll never have that. I'll never even have half of that. So I went ahead and bought a G10 epoxy shaft. It's 1/2 inch diameter, so it's new in the box. I haven't cut it and put it in yet, so I just haven't had a chance. So there were a couple guys talking about chain drives, and it's nothing special, whatever. But this is new to me, and this amp is like a project. It's like I've said before, probably won't even use it, or if I do, it'll obviously be within the legal limit, but I'll have no key down limit on the thing. This isn't some roller inductor amp or Henry Kilt or some piece of crap, you know. So I have the parts. I work on amps all the time. That's what I do, and this is just a fun project. I take that back. I don't have all the parts. I have all the expensive parts. Things like sprockets and these, I mean, stuff adds up. These two brass sprockets were like 60 bucks or so, and then I had to buy the small sprockets and the ladder chain. And this is an awesome company. They're in New York. I've been using them for years. This is the metric catalog. I have the standard inches, whatever catalog upstairs. It's SDPSI. They're in New York. Cool stuff. So I'll go over everything I did, and I'm getting there. I'm almost there, almost to the point where I can finish tapping the tank coil, and once that's done, the rest is smooth sailing. Well, I'm going to set up the protection circuit to drive the stock meters. That's going to take a little time, but as far as the input and output networks, that's basically the hardest part, other than metal fabrication for an amp. I'm reusing a cabinet. When you have to build one from scratch, that's a lot of work. But then the output network, setting that up, that's a lot of work. The proper RF layout. So once that's all done, which it's almost done, almost have that completed, then the rest I've done a million times. Okay, so I have the two shafts here that will couple with the turns counters. I'll show those in a second. I have these. I already have 4 of these. 2 of them are 1/8 inch and 2 are 1/4 inch. So I'm going to draw out the 1/8 inch ones so they fit the shafts because they're all 1/4 inch. So basically, I'm going to cut this shaft down. I'm going to cut the shaft down on the back of the turns counter, and this will slip on the shaft, and there'll be one on the turns counter side so I can slip the shaft off the. I'm sorry. I'm tired. I got up at 4:30 this morning. It's now past 10. So these shafts will be cut down, and a couple of them will go through bushings in the front panel. One's like this. And anyway, so slip the front panel over the shafts, and this will couple. So the plate and load controls will couple right up to this one. This one over here and that one over there. So this is the plate, this is the load. Easy peasy. I thought about setting it up so I could pop the chain on and off. It just would have been a pain. I even came up with a tensioner assembly. I took it apart, but basically it would have been like this. Anyway, no longer needed. Would have had a sprocket and then a spring and a shaft to go through. Actually, I even marked it. But so this is nice and tight. No need for a tensioner. This turns easily with a knob on it. I ended up using spur gears. Okay, so when this shaft turns, there's a spur gear on the other side. This is a stopper thing right here. It's like this, like a collar thingy to stop it from sliding in. Then I have a shaft bushing like that, and there's a nut. So one here, one here, one here, one here, and for these two, it has something like that. It has one like this, but there's a clip on either side of the shaft to hold the shaft in place. Same here. It's like this. See, there's like a little clip. That's the bushing here. These are reduction drives. I've already talked about that. So when you turn this, turns the spur gear on the other side. I'll show that in a sec. 2 spur gears, one here, and then it drives this shaft. And it drives the chain. You have the smaller sprocket, drives the larger sprocket, which makes it so it's easier to turn. Learned all about that in automotive class when I was in high school with differentials. So I'll show you the spur gears. One set right there, another set over there, and voila. So took some thought, but she's like good to go almost. Okay, so I'll show you the front panel. These are made by MFJ. I lined plate and load up with input adjustments. I'm going to put another bushing right there, so that'll be the input rotary switch. Got the output rotary switch. I'm going to flip this bushing around. I have to cut the thread so otherwise it interferes with the shaft, the back of the flange area on the shaft coming off the band switch. So that I had to set the chain set up like that, otherwise I would have had to put a knob there and it would have interfered with the meter. So I want everything to look nice and pretty. So I'm reusing this panel, obviously. I have I think I have 4 sets of these meters, so I have spares, and I think I've already talked about that, I'm not sure. But so I've got the 4 meters, I've got the turns counters. I'm gonna have those vernier turns counters. They're made by Amphenol, I think. So those here. So band switch, and I'll be able to use a little knob. This is the bushing for the small sprocket for the band switch chain. I have a multimeter, so it's a multimeter switch, the reset for the overload board, as long as I can get it to work. It has grid and plate overload because this thing originally had an 8877 in it. So standby operate will be right here. I'm not sure what I'll do with this. I might just plug it up right there. So I had to modify the brackets on the back. Got some blood on here, cut myself. So I had to modify the brackets on the back. They were interfering with the, like right here on this edge and right there on that edge. So I'll show you. See, that edge and that edge. So I just have to put them back together. And I also cut the holes in front of the panel. My machine shop guy no longer works there, so I did this all by hand. It was a lot of fun. But a lot of measuring over and over and over again to make sure everything was perfect and lined up and level. So I'd have to do the math, but basically for every turn and a half in one of the turns counters, I get a turn out of the capacitor. So I'm going to have to, I didn't install the screws yet, but I'm going to have to map out of a chart, and I'll type it out of where the capacitance lands for each capacitor based on the amount of turns. I have plenty of turn capacity for each counter, so that's not a problem. But I'll say this again, and I've said it before. I have the parts, so that's why I'm building this. I'm going to run it within the legal limit. If I use it, I might use it a little bit, might use it a lot. I used to like talking on AM on 80 meters, so that's hard on an amplifier. You know, if I were to build an amplifier with a 3CX1500, that tube's like over $2,000 for an iMac. You could get a Chinese 6000 for like 1400 or so. I mean, it's like way more robust grid. You know, it's just, you know, people say, oh, don't you have a tetrode? Da, 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 da. You know, I have a big tetrode. I'm getting rid of that. It's too big. You just get like a little solid state amp, like a, you know, first off, my 200 watt transceiver will put, you know, will easily do the legal limit with that. But if I wanted, let's say the FCC needed hams to carry communications like they had us do during Vietnam or during a natural disaster, if I needed more, like an ALS 600, you know, some little tiny solid state amp. And yeah, those Ameritron amps, if they've been gone through, they're fine, you know. So, you know, way more, like, it's just way more simple, just way less complicated, you know. Sorry, I'm tired. I got up at 4 o'clock this morning, so yeah, just I'll start over. Just way less complicated, just protection. The thing just should take a beating and just keep on going, and it's not some intermittent thing. It's a CCS rated box, not some big tube box with a 20 amp inductor or roller inductor or whatever. You know, if I'm going to build something, if I'm going to do something, whether it's repairing something or whatever, it's done right or not done at all. And you know, like I said, this is just the project. It's for fun. It's something different. You know, I'm learning a lot. Process. I don't know everything. There are some people that think they know everything, but they tell everybody they know everything. But I don't know about that. But I'm learning as I go along, and it's a lot of fun. So, and I thank everybody for all the comments. And if you have anything to add to it, anything positive, I'm open to ideas. You know, I mean, Jim's given me some help with it, and like I said, after this is done, I'm considering making some for some, you know, for hams outside the United States. You know, they're really, you know, I don't know if there's anyone really making anything like this. I know there were people making ones with roller inductors, but you know, you can only talk for so long on an undersized inductor before you smoke it. Those inductors aren't cheap. So anyway, I'm gonna wrap this up. I'm gonna post the video, and I'm going to bed. I'm tired. It's almost 11 now. So thank you for watching. I really appreciate it. And if you need an amplifier repaired, feel free to give me a call. My phone number is 203-892-4119. I put some grease on this. It was like my way of seeing if it was still rubbing against the bracket in the back of the turns counter. But I am so happy, so happy, so happy. You can ask Jim. I called him ecstatic. I'm just so happy that this worked out. I was originally going to put the spur gear on this side with the sprocket and then have it set up so I put the chain on from underneath, and then the spur gear and the sprocket wouldn't work next to each other because I only have so much distance between the inner panel and the outer panel. But I'm like, oh, why don't I just put the sprocket inside the RF deck? And it worked. So, but okay, that's about it. So please like, share, and subscribe, and I will be back Monday with, most likely Monday, with the 30L1, as long as there are no surprises. But have a great weekend, everybody. 73.